So now we're welcoming Michael Poon. He is a PhD candidate within the David A. Dunlap Department of Astronomy and Astrophysics. His talk is titled Seasons Across the Universe.
Welcome, interplanetary travelers, to Uranus, the icy jewel of our solar system. I hear some folks here are from Toronto. You'll feel right at home. Winds on Uranus hit a breezy 900 kilometers per hour, just like walking out of Union Station in February. Sorry, is that too cold? I've got good news and bad news. The bad news is that here on the North Pole on Uranus, the sun will not rise for 42 years. The good news is I can tell you why. Uranus, where we are today, is tipped almost completely on its side, meaning it essentially rolls around the sun. Similarly, Earth has a tilt, causing seasons as different parts of the Earth receive different amounts of sunlight throughout the year. And the reason Earth and Uranus are tilted is that a long time ago, a massive object smashed into these planets. These tilts tell us stories about how our planets formed, and we want these stories for the over 5,000 planets beyond our solar system, known as exoplanets and shown as gray dots in the background. It would be fantastic if we had this window into their lives, and my PhD thesis aims to do just that. Since the discovery of the first exoplanet, over 30 years ago, astronomers have only measured the tilts of 4 exoplanets. As part of my thesis, I measured one of these tilts, shown as this green dot on the bottom. This measurement was years in the making, requiring multiple observations from the world's largest telescopes, both on the ground and in space. Early measurements relied on statistical assumptions that only work for specific exoplanets. I developed a more general method that can be used in the future for all exoplanets, and it more accurately measures a planet's tilt. Using this method, I discovered the first ever exoplanet that's leaning sideways, like Uranus, showing us that distant planets might not be so different from ours. As an astronomer and an astrophysicist, my goal is to not only find exoplanets, but to explain their physics and how they got there. By measuring how exoplanets are tilted, we can begin to uncover the seasons of distant and unexplored worlds to help answer life's biggest questions. What is our place in the universe? Is there life out there? And are we the only ones who complain about the weather?